All right, good evening, everyone. Please, I hope we are all doing well too. Okay, so we will continue from where we ended. So, on our previous meeting, we did the subsetting and also we confirmed whether an item is part of a particular list of items that we provided using the is in and then the negation, which is the approximation sign. So, today we will quickly move on to sorting. Okay, so um, okay, all right. So with the sorting, so when you were talking about list, so provided we have a list of items, so let me call it my underscore list. So when it contains a list of values, let's say 4, 10, 7, 17, let's say 25, let's say 2. Now we can decide to sort these items within the list. How do we go about it? So we can say sorted, then we use the list as an argument. So my list. Okay, so this is going to provide our list being sorted. And another way that we can actually do the same thing is by saying that my underscore list dot sort. Okay, so we use the sort method on the list. Okay, so I just have to say my list. All right. All right, so we can see that both of the two implementations actually sort our values. However, this sort method changes the values in position, but the sorted creates a copy of the list whereby you have a copy, whereby your original list is not being changed. All right, so in the same way, so similar way, you would like to sort your data in your data frame. And what A stands for, one like to sort the data. Okay, so we can look at it from one point. Maybe you have a data set. Maybe you want to figure out the top 10. Okay, so the top 10 are supposed to be, you are dealing with numbers. So if I want the top 10, I just have to arrange the numbers in such a way that from the highest to the lowest, I can extract the top 10 from the highest to the lowest arrangement. So this makes sorting an invaluable functional method that we use on data frames. What is the implementation? We can implement the sort using this particular syntax over here. So with the syntax, we say that the data frame, which is the data frame that we assign to our data. So if you recall, before we assigned this data, or before we started with our code, we wrote something like df equals to pandas data frame. Okay, and then within the data frame, we provided the path to the file that or the data that we want to work with. So this df over there is the data frame that was created from the data that we passed or we are using in our work or we are analyzing. So that is where the df comes from. Okay, so this df, so the data frame or the data frame of your data dot sort values. So one thing that we will notice is that here instead of using the sort or sorted, the data frame has its own way of sorting. So it says that the sort values. So when you say the sort values, then you provide which column do you want to sort. And then here you provide whether you want it in an ascending order or descending order. If you say ascending equals to true, then the pandas is going to sort your data with ascending order in mind. But when you say the ascending order is false, then pandas is going to sort your data with um, false. I mean with in the descending order in the opposite way, in the opposite form of the ascending, which is descending. Okay. All right. So the behavior of this dot sort values is similar to that of the list. Okay. So let's see an example for ourselves. Please, I hope I'm audible.
Good, yes, you are.
Okay. All right. So our data. So I would like to load the data for us to have and for it to guide us. So I'll say df.head, and then I want to print the first 10. Okay. So the first 10. So this is the data that we are working with. Okay. All right. So apparently, we've created some. Okay. By the way, let's take it like that because like once I was preparing it, I created some other columns. But however, we have a generic column. Here I'm coming. Let me just modify. I want to use the original one. Okay. So we loaded our CSV file over here, and then we have our data here. So the df. Okay. So now once we have, this is our data. Okay, the original data, this is how it looks like. Here we have this and that. All right. So let me just go. Okay. Sorted. Okay. So now we have our data here. So in this case, our goal is to sort the most cases. Okay. So it's a COVID data, and then it's COVID data based on continent and also country. So we have continents and then countries, and then under these we have the confirmed cases per country, and then we have the number of deaths per country, and the number of recovered cases, active cases, new deaths, and so on and so forth. So it's kind of a data, a record of the impact of COVID-19 on countries. So in this case here, what we want to do is to actually find most. So we are going to sort the data by the number of confirmed cases, and then find which countries or which regions have the most confirmed cases. So with that, there are many ways of going about it, but one of the easiest way to actually tackle this is to use the dot sort values function. So just as we saw the syntax over here, we provide the source values, and then we provide a column name and then ascending, whether it should be the ascending or descending. So if we will recall, we realize that this confirm is actually a name of a column from our data. So we have the confirmed over here. So with that in mind, what we can do over here is to provide a name, and then we say that ascending false, meaning that it should arrange the data in descending order. Now we are saying that most cases, which is this variable that we've created, so we only want to print and we want to subset a particular column. So if you joined last time, our last meeting, we realized that we can subset columns by providing, or we can subset columns by providing a list of the columns that we want to include. So in this case, we want to include the country origin, confirmed deaths, WHO origin, and then we want to print the first 15. So when we run this code, these are the top 15 countries by confirmed cases. Okay, so you see that our data is voluminous. It has 187 rows. So with all these rows, how do you identify which countries have the top 15 countries with most confirmed cases? How do you get to know that? So you can do that by just using the sort, and then you just print to the terminal the first 15. So by this you will get to know that US is the first country with the most confirmed cases. After that, then Brazil, then India, then Russia, and then on the top 15 list, Italy is the last country. So with this, you can see that there was no country from Africa. So this can even, okay, there was one country from Africa, which is South Africa, which is in the 5th position. So by running just this analysis on your data, it gives you a clue of the top 15 countries with the most confirmed COVID-19 cases. So that is for one particular aspect. What if maybe you want to find which country has um, the highest fatality case ratio or the highest death? So that one we are using the same implementation, our data frame or our data dot sort the values, and then you say that deaths and then over percentage, which is a column name from our data. So when you get to our data, you see that we have deaths per 100 cases. That is the number of deaths per every 100 cases. All right. So we will pass that column name as an argument, and then we will specify whether we want it to be ascending or not. So in this case, we are saying that ascending equals to false. So it means that descending. And then the columns that we want to print. So you realize that initially we have many columns, but when you specify the columns, it's limited to the number of columns that you want to print to or you want to view. So in this case, we are printing the first 10 values and then we specified our columns. So by running this code, you will realize that now we have the countries with the highest death rate. So by comparing these data, you can say that in the case of US, though they had a lot of confirmed cases, but when it comes to the number of deaths per 100 cases, they are not the top countries, and they cannot be found over anywhere here. So it is out of some of these data analysis that people begin to ask questions, which leads to research. So why is it that US has a lot of confirmed cases? However, their death ratio or deaths per every 100 cases is very low, and it's such that they are not part of the top 10. So this can help us to maybe do our research to see what is making the US have that kind of a result or data. So you see that by just using these, you can draw insights from your data to communicate it to people or to tell people what is there. Okay. All right. So I think maybe we can add the WHO region theory so that we see. So WHO region. Sorry. So the WHO region has been added. So you realize that most of the countries with highest death per 100 cases are in the Europe. Okay, that's top 10. Most of them are in the Europe. Okay, and then one is in Africa, and then one is in the Eastern Mediterranean. So by just doing this, it gives you a lot of insights about your data, which you can communicate to stakeholders to help in an informed decision. So these are some of the avenues where you can use the sort values, or you can use sorting of values to draw insights from data, and we can apply it to any of the columns. Now let's come to multiple columns. So initially we've done it for single columns. So what of multiple columns? Maybe we want to actually sort by multiple columns. Now, what we do is that if we want to do for multiple columns, they are not a single data type, they are multiple data type. And so we need a data structure to handle that. And one of the data structure that is appropriate for this particular task is a list. So we pass all the columns that we want to sort as a list. Okay, so it's that we have the WHO region and then the confirmed cases in a list, not as single individual values. And then in this case, since these columns are two, when it comes to the sorting as to ascending or descending, we have to provide two for them. So each of them. So for the WHO region, should we sort it in ascending order? If it is true, then you specify true, and then if it is false, you specify false. However, you put all of them in a list. So what happens is that in this case, um, the Pandas is going to sort the cases based on the WHO region. And then when we look at the WHO region, it has to do with the continent. So it's going to sort the continent because they are not values. It will sort them in alphabetical order. Okay, all right. So by so do you realize that this is being sorted in alphabetical order, and then for the WHO, sorry, for the confirmed cases, it will be sorted in descending order because the ascending parameter is false. Now, one thing that you have to note is that when it comes to the sorting, what Pandas does is that it's assigned priority to the first argument. So since the WHO region is the first argument, what happens is that it's going to follow that particular protocol. So Africa will come first and everything will come first. It is only when that particular, I mean, in the alphabetical order, maybe there are countries. So maybe you see that the alphabetical order, all of them will have Africa, Africa. So you know that Africa will come before Europe because Africa is A and then Europe is A. However, there will be cases whereby the values for the confirmed cases for Europe may be more than that in Africa. However, that will not come to pass because will not that will not be seen as as you sort your values because priority is given to the WHO region as in the alphabet first before the numbers. So in this case, what I'm trying to say is that when you have the list of Africa, so you can see that there will be Africa, Africa. However, the confirmed cases will be arranged in descending order. So that will occur throughout all the African data before you move on to the next WHO region, which comes next after Africa in alphabetical order. So let's see that in action. All right, so I think we have Africa, Africa. Let me just do it like 30 so that maybe we can have a glimpse of what I'm trying to say. Like the African countries were many, so let me try with 50. Okay, 50 should move to something else. Okay, so you will realize that let's come here. Okay, so you see that here. Come on. So you see that for the Americas, the number of confirmed cases is around 4 million. Okay, okay, but okay. However, that of the Americans did not come before the Africa because of the priority. Because when we are arranging it, Africa comes before America. So um, please, I'm coming. Looks like mine. Okay, so let me continue. Maybe it will come later. So you realize that though there are American have confirmed cases that are greater than that of Africa, but they just come after Africa because of the priority. Because Africa comes before America, and so it has to deal with all the Africans and sort their values in descending order. Afterwards, then it will move to the next in that particular order. So please kindly be patient with me. My machine is stacking a bit, so I don't know why it is stacking, but it's just stacking. So it's now back, so we can continue. All right, so that is how we do. So always the priority will be given to the first and then the second. So let's, for the sake of um, you know, for the sake of learning, let's just interchange it and say WHO region. Okay, and let's see how it behaves this time. So isn't that when we change the positions, priority is being given to the confirmed cases, okay, rather than the WHO. And here, because the confirmed cases, we say that ascending is true, it arranges it in ascending order. So basically, you need to put that in mind, that based on the order that you put your columns, the priority will be assigned to that. Right? But once we change it to WHO and then confirm cases, the presentation of the data will be different. Okay, so by this you can also say that South Africa is the country with the highest, and then Ghana is the third country with the highest. So how do we know? But you see that in this case, when you are giving the data, you were never told that Ghana is the third highest, but by just analyzing using your source values, you cannot say that, oh, so South Africa is the highest, Nigeria is the second highest. So basically, that's what the analysts do, and then they provide the data for us in news and everything, and then we get to know them. Okay, so we learned about filtering the other time. So we are going to put the filtering and then the sorting together. How do we go about it? So, sorry. So, so in this case, what we are going to do is to find the top 10 African countries by confirmed cases. Though you can use the sort to do, okay? You can use the sort to do as we did over here. But however, there are also many ways of killing a cat. And one way you can do is to just use this particular code. What does this code do? So now I would like to disassemble this particular code for a better intuition and understanding. So if you were able to join our last meeting, you realize that when you say DF and then you say WHO region, okay, and then you say equals to Africa, what you are going to see is that this particular code is going to give you true, false, as Pandas compare the WHO region that meets or that is equal to Africa. Okay, now once this particular code is done, we realize that that's true or false can be subsetted, which we learned when we were doing the pandas. How do you subset it? So you use the same DF. So you provide this particular condition over here into square brackets. And once you do that, it subsets or it filters the data. So all conditions that are true will be printed. So that is what this particular code stands for. Okay. So it selects all WHO for the data in row wise. It selects all rows that has Africa in the WHO region. So you realize that let me just show you something. So in the WHO region we have European. So that is that. So every row that has Africa, it will select it. That is every row that is equal to Africa. Select that. That is what this particular code is doing, which is what we have over here. Now, once we have that code, then we say that the sort values, which we know already. So the sort values, we are going to sort values. Which column are we sorting? We are sorting the confirmed cases column. And what should be the criteria? We want it to be descending order by setting that ascending to false. And then once we are done, we want to print the first thing. So this same code can be written like this, like as one line. Okay, but for the sake of clarity, See that this one line makes it a bit um, difficult to read. Okay, so once you break it like that, it helps you to know that okay, this, that, and this is doing this. So this can be for sorting, this can be for filtering, and this will be for getting the first thing. We choose the columns that we want to print. So top Africa, then we select these columns. Now let's run it and see. So you realize that we have the first 10 and the top 10 African countries with the highest confirmed cases. So here you can see that South Africa is the first, and then Madagascar is the last on the list for the top 10, and then Cote d'Ivoire is somewhere there, and Kenya to Ghana is the third, and so on and so forth. All right, so up to this stage, please, if you have any question, you can ask. Um, so there is one thing that it's good for us to note in terms of analyzing data. So when it comes to analyzing data, we have something that we call the adding new columns, because there are times that you need to perform some calculations on the existing columns to create a new column which you would like to show. In this case, we are going to implement some code that will help us to achieve that. Now we can draw inspiration from this, or a recall from this. We can relate this particular creating of new columns from what we did when we were learning dictionaries. So we realize that when we have a dictionary can say my underscore dict. We say it's a dictionary, and then we just provided that and say something. So what should be that thing? So let's say A. Okay, then A. Then we say 4. Okay. Let's say B. So B. Then we say 5. Okay. Now once we have this particular dictionary being created, we can also add up values to the dictionary. How do we do that? So we can say that so let me just create the my dict properly. So we can say my underscore dict, which is your dictionary. Then if we want to add C, okay, and then we want to assign the C to say 4. Okay, so let's just run the my dict and let's see how that's going to work. If okay, so you realize that here the C has been added to it, right? Has been added to our dictionary. And then we learned this one even from list. That's one when you want to change something in the list. All right, so with the same implementation, we can also add a new filtering. So this particular code can be 4 plus 8, and that is going to work perfectly for us. So now you can see that we've added a new key called C, and then with that new key we want 2 values. Okay, or we can even do this my dict. Okay, my dict A plus my dict B. Okay, when we run this particular code, what this will do is that the third dictionary, the third key that we are creating, we are assigning it to the sum of the first and then the second, which is the my dict A, then my dict B. So apparently the C should be 9. Let's run it and see whether we will have that. So you can see that the C over here is 9. So by so doing, we've added a new key or let's say column to our dictionary by the addition of these two values. Let us notice the implementation. When we have our data, so provided let's say we want to compute the active percentage cases. Okay, so that is um, we have the active cases, and then we have the confirmed cases, and then if we want to find we want to find the percentage active cases. So the formula is to divide the active cases by the confirmed cases and multiply it by 100 to get the percentage. Now how do we go about it? We create that new column just as we did over here. So this one, instead of a dictionary, we are using our data frame, and then we say that what is the name of the new column that we want to create. We call it active percent. Okay, and then what should be its calculation, or what values should be used in its calculation. So here in this case we are using the df. So you can see that here there is a bracket over here. This is just for mathematical operations, for for the sake of logic. Okay, because we are dividing this, we just put it in brackets to multiply. Though pandas or python automatically obeys board math, but when you put your operations in parentheses, it also helps in its clarity. So we are dividing this by that, which is the same like this. Okay, so we have this df active, we have the active column in our data, and then we have the confirmed column in our data, just as we have the A in our dictionary already, and then the B in our dictionary. Then once we are done, we multiply it by 100. So by multiplying it by 100, it's going to give you the percentage. Now we are saying that that same column, that new column that we've created, what we are going to do is that we are going to round the percentage. We are going to round the values to two decimal places, so that we don't have more, because more values like that does not make the data presentation. Okay. As soon as we are done, we select some columns, and then after selecting the columns, we basically print the first 8. So let me just run the code and you will see that. Okay, so you see that in this case we have the active, which was initially already in our data. Then we have this confirm, which was also initially in our data. However, when we look at this percentage, active percent, you see that it was not initially in our data because we just created it. And then we created it by dividing the active by the confirmed and multiplying it by 100 and rounding the values to two decimal places. So that is the values that we have. Okay, so you can see that this column, third column, was derived from these two columns. So based on what you want to do, you can create as many as columns that you want. And it is not imperative that after creating that column, you have to use the entire data in your analysis. Using this particular code, you can select a particular column that you would like to use in your data analysis. So that is that for creating new columns. All right, so we can also create another new column. So in this case, we say close cases. Okay, so in these cases, we are talking about cases that um, um, that have whether the person recovered from the disease and the virus or the disease or died. So in this case, we say that the column that we are creating, we provide a name, and then the operation that we want to do is we want to add the recovered plus the deaths. Okay, so by doing so, what happens is that these and these will be added and a new column will be created, which is the summation of the recovered cases and the deaths. Okay, now once we are done, we can also create another one called the closure percentage. so that what percentage of all cases have been resolved, and then we implement the calculation that solves that round it to two decimal places. Once we are done, we can just select all the new columns that we've created in addition to other columns that we want to show, and then print it to have a fair knowledge of it. So you see that we have the closure percentage rate and then the closed cases. And likewise, once you've created this particular new columns, you can run the sort on it, okay? So by saying that sort these values, you can sort it to see the highest and then the lowest. Okay. So we've done with numerical computation. What of categorical computation? Maybe we want to check whether some values meet a particular condition, or some values of our data meet a particular condition, and create a new column whereby we tag them high or low. So in this case, we are going to just implement some numpy. So you know that if you recall the where when we were doing the numpy, so that's why we need to import it. So this numpy, this where does not belong to pandas, so it belongs to numpy. So we need to import numpy before we can use it. So the new column is case level, and then the case level, this is the condition. We are saying that where the confirmed cases is greater than 100,000, target high, or else target low. So in this case, pandas is going to look through, numpy is going to look through your data, and then the places where the values are greater than 1,000 is going to say high. It's going to say high, and then if it is less than 100,000, it's going to target low, giving its categories. So once we are done, we can just print the value count. The value count, as we learned the other time, count the number of unique values within a particular column. So in the case level column, we have high or low. So what this particular code will do is that it will count for the number of highs and then the number of lows in our data. All right, once we are done, we select few columns that we want to show to the terminal, and then we provide the sort values method function on it to sort it in according in descending order. So let's see that one also. So from this particular data over here, we can see that based on the data that we have, 163 of the countries have low confirmed cases. Okay, that is the threshold is less than 100,000, and it's only 24 people, 24 countries, and it is only 24 countries that has confirmed cases that is greater than 100,000. And this is a very good insight about your data, and its implementation is very simple. As we've done here, just some few code, you are able to generate a lot of understanding. So the reason why Pandas is easier than Excel is that if you want to get this in Excel, it's going to be a bit harder. But you see that with this, just some 3 lines of code, you are able to get all this information, get a summary of how many of them are low and then how many of them are high. So once we are done, we print to the column, so country rate and confirmed cases, and then case level as we have over here. And then we've sorted them in descending order. Now, when you are sorting them in descending order, in this case, we are sorting them by the confirmed cases. So you can see that it is the US, and then the Brazil, the India, all these ones are high because they have confirmed cases that is greater than 1,000. And it cannot be only the confirmed cases, it can be any of them. So let's try for that. Okay, maybe we want to know the depths. Okay, all right, so when we try for the depths, So you see that now, um, the deaths. So you can say that it's only one country that's recorded death that is more than 100,000. Okay, and that is the US. Okay, okay. So maybe the 100,000 is too much. So maybe we have how many countries recorded death that's greater than 1,000? We can do that. So you see that 44 recorded deaths more than 1,000. Then 143, the deaths or number of deaths in those countries, and 143 countries have deaths that's a number of deaths that is less than 1,000. So basically, that is what you can do, and you can do this on any of the columns that we have. Okay. So we have a more refined classification. That is, we will call it a um, nested classification. So we are creating a new column called severity. Okay. So with this severity, we want to create a particular criteria. What do? We say that np dot where df confirmed greater than 500,000. So if the number of confirmed cases is greater than 500,000, target critical. So where then we created another where. Okay. So where df confirmed cases is greater than 100,000 high, and then is greater than so yeah, greater than 100,000. Okay, and then here greater than 10,000, say medium. Okay, or else low. So the condition is like if it is greater than um 500,000, you target critical, or else. So in this case, instead of providing something for the else, we are using the where again. So it will look for this condition. If or else, if it is greater than 100,000, target high, or else then we use a ym, then p where again. Target medium when it's greater than 100,000, or else because our condition is done, we just provided a text that it should Pandas should target with, or NumPy should target with, which is the low. So let's see that also in action. Okay, so you see that here it has performed that work, and by this we can say that 107 countries had confirmed cases less than 10,000. 56 had cases greater than so medium greater than 10,000, and 20 has cases greater than 100,000, and then 4 had cases greater than 500,000. And we can print our data to see those countries. Okay, so we can also sort it. So sorted, um, that's sorted underscore values. Let me say ascending. Let me say true. No, so let's say false. However, I'm going to use the confirmed as my column. Okay. Okay. Okay, so let's see. So source value, then I said okay. Here. Let me just so here. But that's the spelling line. Let me just copy from here. Oh, sorry. I don't have that one to us. This Okay, so I think it should be working now. Okay, so the reason why the error was there is that the columns that I've selected, the confirm is not part, so I cannot work on that. So once we print or we try to output this data, we will recognize that now we have sorted the data in descending order. And by this data, we can tell which of the countries were critical. So we say we have US, Brazil, India, and then Russia. Okay, and then those that they were high, and so on and so forth. Okay. Now, in this case, maybe we would like to also check for use functions. Okay, we know that functions are reusable code. So maybe we want to write a function to perform an operation on um, our entire um, column. So for us to do that, we can use the apply. So provided the logic is too complex. So you see that for here, if there is like about 10 logic, then we have to write this. It's going to be so complex because here we are going to use another NP where to create the new logic. So that will make it complex. So why don't we use a function to simplify it? So how do? We create a function as we've learned earlier how to create function. So we say def classify recovery, okay? And then we have an argument here or a parameter here called a row. Now what we are doing is that rate equals to row recovered over 100 cases. Apparently this row over here will be your DF because we say that the rate equals to row, then you are selecting this particular column. So if I'm to select this column, then it means that that row should be my data frame. So once we have that, then we are going to specify our conditions. If rate is greater than 80, so these are all conditional statements which we have learned. So if rate is greater than 80, return excellent. If elif rate is greater than 60, good. Elif rate equals to that. So we specify that condition. And you see that this one is a bit simpler and easy to read as compared to the NP where that we were doing. So you may use this when the arguments are few or when the conditions or the categories you want to create are few. However, if it is a bit complex, you have to just use a function. You have to create a function that will do that work for you. Now, once we are done creating this function, we need to apply the function to our data. How do we do that? So we say that DF recovery category. So this creates a new category. Okay. And then we are saying that to that new category, what are you supposed to do? So we see that df.apply. So if you want to use the function, initially when we were learning, we said that you have to say classify, okay, underscore recovery. Classify underscore recovery. And then we do this and then we provide the argument, which will be the row. But in data frame, when you want to use a function, that is not the implementation. So how do you implement it? So you use the data frame. So you say that data frame dot apply. So it means that you want to apply a function to something. So what function, what do you want to apply? So this function, which is the function over here. Okay. And then on what do you want to apply the function? So we want to apply the function to all the rows. Okay. So if I'm applying the function to all the rows, I have to set the axis to 1. So once I set the axis to 1, what Pandas will do is that it will apply this function, this particular criteria, to all the rows in our data to create this new column. So for the first row, it will look at the recovered per 100 cases, and then it will check for the condition. If it is greater than or equal to 80, it will target every row. And as it is targeting it, it creates a new column for this. And as we know already, Pandas does this simultaneously, so it is very fast. So once we are done, we can count the number of poor, moderate, excellent, and good that we have by using the dot value count, which counts all the unique, but the number of times each unique value appears. And then we can select some columns and then print. Let's see. So you see that the number of countries that had recovered rate greater than or equal to 80 are 67. And then those that have meet this condition are this and that. So with that, you can also present your data in this way and use it for further analysis. Please add to this page if you have any question you can ask. Any question, please? Please, is there any question? Okay, so if there is no question, then let's make progress. So that is that for applying functions to your data. So we have something that we call the aggregation. So you are summarizing a column. So in the beginning we use describe, and the describe summarizes the entire data. But if you want to summarize maybe a particular column to get some information, you like to use aggregation. So we create a variable called confirm, then we assign that confirm to the df, which is the confirm column. And then we want to return the sum, the mean, the median, the standard deviation, the minimum value, and then the maximum value. And here the IDX max returns the highest value, okay, in that particular data frame. So let's see that in action. Okay, so here confirm cases. So now you can see that we have our total, mean, and everything. And then here in the idea section, we see that df.log. Okay, so the log takes a label. So what are we looking? So log, then we provided this argument within the log. Okay, and what does this argument do? So we see that df.confirm cases, we are finding the maximum value, and then for the maximum value, which country, okay, has that maximum value, and it's going to give you the US because US has the highest confirmed cases. All right, so that is that for the confirmed cases, and that is what we call the aggregation. Okay, so we are returning the statistical summary of the data. So this one, it can be WHO region also instead of the country, or okay, so with that, that's going to give you the Americas. Okay, so what it does is that it just select the highest value, and then it looks up in the WHO region the value and the country or the continent that has that highest value in the confirmed cases. So we can do the same thing on this, so depth analysis. Okay, so how many deaths were there? You will not see that in your raw data, so you need to calculate it. So the number of deaths, and then the mean death per country, maybe the country with the highest deaths, and then country with the lowest death. So the same implementation. So IDX max and then IDX min. So it just look up for the country with the lowest, country with the highest. So by this, you can see that the total number of worldwide deaths is that, and then the number of mean per death too is that, by just using the aggregation. So you know that with this, we are just implementing them one after the other. What if we want to perform multiple aggregations at once on different columns? So this one is one column. So when you have multiple columns, what do we do? Are we supposed to write this aggregation particular this analysis code for each of the columns? That's going to be a very great work. So we have multiple aggregations. What do? So we select the columns that we want to find the aggregation, then we use the dot aggregation. So then in the dot aggregation, what statistical descriptive statistical method do we want to find for these? So we want to find the sum, mean, median, and mark center. So you have and then we want to just return them to one decimal place. So when you do that, you can see that it gives us a beautiful table with confirmed cases, the total, the mean, the median, the max, and then the minimum. So with this data, you can see that there were cases that some countries did not record any death, and then there are some countries too that there wasn't any recorded cases because the minimum value is 0. All right, so that's for the aggregation. We also have the group by. So group by is more like pivot tables. So in pivot tables, you can group the items. So maybe for categorical data, low and high, you can group them, and then it will give you their totals. So in Pandas, what you can do is that we use the group by, then we specify the categorical column. So group by, what column do you want to, then what categorical column do you want to group your data by, and then what value, and then what aggregation. So let's see that here. So in this case, we want to group the data by the WHO region. Okay, and then by the WHO region, what we want to do is to retrieve the total sum per WHO region. So this is going to give us all the continents. Okay, so all the continents, and then their number of confirmed cases, their total number of confirmed cases. So let's do that. So you see that we have this particular data over here where we have Americas and then the total number of confirmed cases, Europe and total number of confirmed cases, Southeast Asia and total number of confirmed cases. And this code, just this line of code, will do all these things for us. Okay. So once we are done, we can make progress to another one. So we are grouping by the WHO region, but in this case, we want to find the mean of the death per 100 cases around it to 2 decimal places. So let's see. So this will basically categorize them. Okay. So you have Europe, you have this, and then you find they are the means of the death per 100 cases in our data. Okay, so that is that for the group by. So you can group it based on anything. So maybe you can group it by low or high. You can group it, so initially we created some columns that were low or high. Let me just get that. So recovery category, let me just copy the name and let's implement that also as an example. So let me just copy this code, place it here, group by. Okay, recovery, and maybe just the same thing. So let's run it and see. So let me just call it regional death rate. So that you see that there is a group by. Okay, so let me just use the confirmed cases. So sum. Okay, so we have the confirmed cases over here. Okay, so let's see. So this returns so the number of excellence. So based on our criteria recovery, the total number of um, I think that this shouldn't be there, but I'm just using it as an example that you can group by any categorical value and return any aggregation that you want to. So what if we want to do multiple aggregation? So we are grouping by WHO region, and then the aggregation, we want the country. So for the countries, we want to count the number of countries, and then for the total confirmed cases, we want the sum, and then for the total deaths, we want the sum, recovered sum, and this we want the mean, and so on and so forth. Let's see, is that similar thing? So you see that we now have a data whereby you can see that it's just a good summary. So WHO region, how many countries? American 35, total number of confirmed cases, total number of deaths, total recovered, mean death rate, and then mean recovered rate. So you realize that these things were not apparently or initially in our data, but per analysis, we've been able to extract this data. And by this data, we can make some plots to just visualize what we have already simplified. So we can also group by the same group by on a computed column. So you see that this severity, we just created it to determine the severity of cases. So we can say that severity and then the countries equals to the number of countries. So we are going to go by the severity. So how many countries? Then we are going to return that the average confirmed cases and then average deaths and the total deaths. So when we do that, so we have the severity and then critical, the number of countries that are critical is 4. The number of countries that are high is 20. The number of countries that are medium is 56. Low is 107. And for the critical countries, the number of average confirmed cases is this, average death is this, and then the total death is also this. So you see that we've simplified the data so beautifully. Okay, so that is the wonders of Pandas, and then it's more of like we are just using just one line of code in order to do this thing. Okay, so the value dot count, we've talked about it already. So it returns the number of items, the total number of unique values in a particular column. So if we want to return the value dot count, the percentage, we have to just set the normalized to true. Okay, so the normalized to true, then we multiply by, because the normalized to true says that normalize the data. So that normalization is dividing each of the counts by its total number of items that are there. And then once you divide, you just multiply by 100. So the multiply, we are using the MUL, okay, which is the multiply. So multiply by 100, then we run it to 1 decimal places. So we can just get the percentage also. So you can say that here the percentage of Europe in the total is 29%. Africa is 25, as in um, the number of countries. Okay, all right, because this WHO region, as in the continent, appears per the number of countries that we have. We also have a way of handling missing values. So missing values are values that are none, not a number. Okay, the same as the np.none. So what we do is that if we want to say figure out whether there is a missing number, we say that it's null. Okay, so if it's null, that is if it's a missing number, print something. So it's null checks for whether it's null. If it is true, it will print that. If it is not, nothing will be. So in this case, it's a missing map equals to df dot is null. So it checks whether there is a missing number. If there is, you can return the shape of it. Okay, so this is now will give you a table or a data frame. That's why you can return the shape. And if there is nothing, this one will give you nothing. So we are saying that df dot is now dot sum. This calculates the total number of missing values. Okay, and then he said that missing counts greater than 0. So we can subset the missing count. Okay, this is the missing count. We can subset it by retrieving only columns that have missing counts greater than 0. Let's see that in action. So because in our data initially we checked and there was no missing number, and there is no missing number, so it's not none of these is true because yeah, our shape, the missing dot shape gives you 18721, but however there are no missing columns. That's why these places are empty. Okay, and we also have another method that we call the is null. So you can use either is null or the is null. Okay, okay. So I think that's not um, too necessary since you know there is null. So once you have that, you can just perform some calculations. So you can figure out the percentage of the missing values. So we say that df dot is now dot sum over the total number of data that you have times 100. This is just a percentage calculation, which we already know. Round it to 2 decimal places and print it. So once you are done, you subset it. But because there is no missing values, we will not get any value here. So we are trying to create artificial missing. Yes, hello. Now, so that it can help someone with their analysis. So in this case, we are creating a new data frame by copying the first one. So it means that everything that we are going to do with this will not affect the original one. Okay. So we create a copy, df.copy. So that will copy that to this, And then with this, we are modifying some of the data. So we are saying that look up to the fifth position of the depth column, and then assign that value none to it. Do the same for the 12th row of the depth column. Okay, so these represent rows and these represent columns, if you recall. And then assign the value none to it. So once we are done and then we run this particular code, we will realize that we have some missing number. So missing values introduced. So there's we have 2 and recovered we have 1. So in this case, when we pick some of our these, so let me just pick this code. And then let me run it here. So it's a missing count is equals to df. So let me just modify the demo. That is now okay. All right, so let's see what happens. So you see that this returns the total number of missing numbers, and then it gives you like it prints it to your terminal. So let me just try with another one. Okay. Missing counts. So, okay. All right. So this particular code checks for the missing count that are greater than 0. Then it gives that. All right. So once we are done, I just want to print that one to the terminal. All rows that have the missing. I think there is a way. Let me just do that. So maybe you can say that demo. So df underscore demo. missing counts. Let me see. So that's going to be columns. Okay, so I think the implementation didn't go through. So let's try something else. So let's say demo df, then let's say df underscore demo. And then let's say SMA. Then let's say we want all, then the axis should be the row. So with this, let's see how it's going to work. Just say this now. Okay, so apparently it's not retrieving any of the rows with missing numbers. However, we have to, so it's supposed to work, but I don't know why it's not working though. Okay. All right. So I will check it and then I will let you know. But however, wait, okay. So however, when you look at the data, you see that the missing numbers that we introduced are there. So in this case, under the devs, we introduced it to position 5 from where, okay, so from here, we introduced the missing number and then we can see that. So my goal was to retrieve the columns with the missing numbers. So I think, let's say, let me just try something else by changing this one to A. Okay, so I think the any works other than the all. So what we are doing over here is to so we are checking for all the is now values on the df.demo. Okay, and then we say that any of the axes. So is there any missing number in the axis, sorry, in the rows of the data? If there is, then print them. Okay, and that's what you, so we have 1 2 3, and apparently we introduced 3 of them. So we have now one at number 5, one at 21, and then 20. Okay, all right. So one way we can handle the missing numbers, which is also the NA, is by just dropping them. So when we say drop NA, what happens is that it removes the entire row that contains the NA. So when we say drop the NAs, this particular row will be removed. This will be removed. This will be removed. Okay, but ideally this is not good for our data because there are going to be countries that will not show up because they contain some missing numbers for just a single column. So here we use that drop NA to remove the missing numbers. Okay, and then we can say that what is the length. Okay, and then what is the length of the drop, and then we can figure out the number of rows that have been dropped by deducting the original length of your data to the new length of the data after you drop the N, and that is going to be 3 because they are 3 and we have 3 rows containing missing numbers. Another thing that you can do is to fill the missing space with missing numbers with something. So in this case, for the devs, we can we can fill it with the mean. So we just calculate the mean, or we set the mean over here as an argument separately, though we can include it in our code, but to make it a bit bigger. So we are just making a copy of the demo. So df field equals to demo, just make a copy of my data. And then we are saying that df field devs equals to df field devs. So for this column devs, what you are supposed to do is that fill the missing numbers, which is the NA, with the mean devs. So run it to 0. So fill it with whole numbers. Okay. So what will happen is that all the missing numbers will be filled um, with the mean value of that particular column. Okay. So once you do that and then you check for missing numbers, you see that there will be none over here, because you've replaced the missing numbers with the mean. And you can replace it with the median, you can replace it with the mode, you can replace it with anything. So we have a lot of parameters for this based on what you want to do. Okay. So we have something that we call the reshaping the data frame. Reshaping has to do with resizing or renaming. So we can rename all the columns again. How do we do? So that def dot rename, then the columns. So this is what we do. We create a dictionary. Okay. So this is more of like a dictionary that we've created over here. So we create a dictionary, and in the dictionary, for the columns that already exist in our data, we specify the new column. This column, new column, old column, new column in the dictionary format. So once we are done, we can print the updated df clean, and then you see that all the data columns have inherited the new ones. Okay. All right, so we've just printed it to the list so that we don't have like all our data being presented here. But you see that when we say df clean dot columns to list, we realize that the countries, we realize that the countries, sorry, we realize that the country, at first it was country origin, now it's country, and then the confirmed is confirmed because we didn't change it. But death per 100 cases is now only death per 100 recorded, as we've written over here. So that is that. Okay. So we can also drop columns. So maybe some of the columns are redundant, we don't need them in our analysis. But otherwise, we don't want to also maybe select only those columns. What we will do is that we can delete them. We delete them by using the dot drop. So focus df equals to df clean dot drop. Okay. So columns equals to weekly percentages and all these ones. So these columns will be removed from the columns that you are going to work with, which you have named the focused df. Okay, so you see that the new columns will be all the other columns except what you dropped. So a bit visualizations we've gone through, so I'm just going to give you a bit and then we call it a day. So in this case, we are just using our old friend Matplotlib. And then here there is a new invention. At first we have to always state or provide a fixed size, and we have to state the grade for every line of code that we do. So in this case, Matplotlib has a new invention. And what do? You can pre-specify all these things before you start working. So you set the figure size. So this will be default for all of your what's the name? Your plots. Okay. And then you set all these ones. The grid is true, then the line, then the alpha. You set all these parameters. So let's just run to load the Matplotlib package. So once we've done that, we are going to create a bar chart. Now look at some inventions over here. So we are grouping by WHO origin, and then we want confirmed cases, and then with the confirmed cases, we want the sum, and we want to sort the values from in descending order. So we just create our fig and then axis, and then we specify. So we are saying that regional totals dot plot. So ideally, at first, we are going to say ax dot plot, and then we provide the original totals, though that one will work. But when it comes to matplotlib, it has a better way of implementation. How do you do that? So you say that the original totals, which is your data frame that you want to work on. So that particular data frame dot plot, and then here you specify the kind. So what kind you want to do, what kind of plot you want to do. So bar plot, if it is scatter, you say scatter. So here in this case, bar plot, and then the color should be still blue. And then you say that the ax should be ax. So ideally, instead of writing like ax dot var, and then saying that regional underscore totals, then say color etc. Instead of doing this particular implementation, we are reversing it. So we are saying that the original totals dot plot. What kind of plot? A bar plot. And then what axis should it use? So it should use this axis. That's why we say that the axis, this axis equals to this particular axis. So once you do that, we are going to see a bar chart, a very beautiful one. Okay, this bar chart gives us the total confirmed COVID-19 cases by WHO region. So confirmed cases, Americans is high, followed by Europe, and then by Southeast Asia, Mediterranean, and Pacific. See that it has been arranged in descending order based on this particular code, but when we take it off, it's going to do it's random. Okay, so you see that it's random, it has been randomized. However, when you use this, it helps in reading the data. Okay, so we can say the bar H because the text are like more. So when you use a bar H, it presents the data much better. So it's the same thing, but we are just using the bar horizontal. Okay, that is a horizontal bar chart. We can do a histogram, the same implementation, and that will give us the distribution of the deaths per confirmed cases where they are centered. Okay, so the death cases are centered around 0 to 5, so here can be like 3.5 to 4 thereabouts. Can also give a scatter plot to figure out the relationship between confirmed cases and deaths. So what's the relationship between confirmed cases? So as confirmed cases increases, we can see that the deaths also increase roughly, because at this place we can see that as the confirmed cases increases, move away from the 0, the death cases also increases. So there is a positive correlation. We can also implement what we call the box plot. So the box plot, I haven't talked about it, but the box plot is able to tell you the spread of the data, okay, within the center. So the 50% of the data, the middle 50% of the data, how is it being spread? So you can see that there are a lot of visualizations that you can do, and it even gives you knowledge of the outliers, okay, outliers of your data. So this is a box plot, and then its implementation is very simple. So you can do it for just a single column, but in this case we want to do it for many columns. So we say that WHO region equals to Africa, and then for the confirmed, and then so let me just explain this a bit as we wrap up for today. So in this case, we are specifying the data that the box plot should use. This is the data over here. And what should the data be? So we are saying that in DF, so you can see that in this case, we say that WHO region equals to Africa. We want the confirmed cases. WHO region equals to Europe. We want the confirmed cases. WHO equals to Americans. We want the confirmed cases. So what we are trying to tell him is that use this data. And what data? The WHO, the confirmed cases for Africa, Europe, and then Americans, and plot their box plot for us to know um, their outliers, and also how the data is centered. So once we do that, we use the ysql log, because once we don't use it, Pandas is going, no, Matplotlib is going to plot every single data, and so the chart will not be nice. So we use the log to give a logarithmic scale for all the data. So it's going to plot the ones that are appropriate and deserve to be known. So that is that. And then we also have a scatter plot. So in this case, the initial scatter plot, we did not color the data. So we don't know which of them is which. So here we can just color them based on um, the, the regions, okay? So in this case, we are still finding the correlation between the deaths and then the confirmed cases. However, we want to know which country or which region, which WHO region um, which WHO region is in what position, because by just knowing the color, you can tell that Western Pacific is very low, as in they have low confirmed cases as with respect to the death, but you can see that the Americans have very high. Okay, so let me see whether I can set a Y limit to it. Okay, to zoom up. To zoom out, there this one. To zoom up, to zoom out our chart. So to do that, I'm just going to say, so VLT. So let me just add that while then maybe I'll set it to, so it should be the X instead. Then maybe I'll set it to, so instead of 4, set it to 2. Let's see. So let's see. Next limit. It's not showing. Just something. Oh, sorry, I forgot that one. Let me just try with something else. Let me 0 and 2. See whether this one works. Okay, so apparently the limit I'm trying to set is not working. I wanted to zoom out the data so that we can actually appreciate more of the correlation. Okay. So once we are done, this is just a dashboard where we created multiple graphs in the same place on the same page. So I'm not going through because it's what we have been talking about, that we are creating all of them on the same page. So apparently you can do as to any number of analysis that you want based on your needs and the questions that you want to answer with your data. Please, I hope that is okay. So we've come to the end of today's session. Please, if you have any question, you can ask.